Have you ever wondered how researchers predict future outcomes about election results, stock prices? Well, one of the main tools they use is called regression analysis, a statistical method that helps us make predictions for the future. To better explain it, regression analysis is a graphical technique that examines the relationship between two or more variables. Specifically, it helps us to see how one variable, the dependent, changes when we adjust the other, called the independent variable. For instance, a very middle school researcher might want to know how studying for more hours impacts test scores. In this scenario, hours studied is the independent variable and the test score is the dependent variable. In a simple regression, we place data points on a graph isolated from one another. Then, we draw what's called a line of best fit directly through them. This line represents a rough equation that lets us predict whatever the dependent variable is in a real context.
Now with this graph right here, we're going to go back to the example that I gave earlier. So imagine that in this scenario, a class of college students has just taken a quiz that's scored out of 10, and they're reporting to a researcher how many hours they took to study for the quiz. When we're looking at the regression analysis, we take notice of two things, the y-intercept and the slope. That's with any analysis. The y-intercept is where the line begins. In this example, it's at 2. So after 0 hours of studying, the average student got a 2 out of 10 on the exam. The slope, or the steepness of the line, tells us the rate of change. In the context of this graph, we can see that after about 2 hours of studying, the students' average score climbed from 2 out of 10 to 5 out of 10. This may be an unrealistic example, but it illustrates the concept very well nonetheless.
Regression is widely used in fields like economics, political science, medicine, and so many more. It can be used to predict voter turnout, visualize economic growth, and estimate the effects of treatments. However, it must be noted that correlation doesn't always mean causation. We must be mindful of the fact that just because two variables move together doesn't mean that one causes the other. Regression only shows relationships, not direct causation. In short, regression analysis is a powerful tool for analyzing data and making informed predictions. It's a fundamental method in research that gives us insight into complex relationships. So next time you see a prediction on the news or on a TV, remember, regression analysis could very well be behind it.